If you're building a physical product and your material costs look good, there's an assembly reality about to destroy your margins. Most inventors calculate material costs down to the penny, but they never calculate assembly labor until production begins. And by then, it's too late, because every second of assembly time multiplies across thousands of units into a massive margin erosion. Hi, I'm Adam Taven. After developing over 2,000 products, I've learned something most founders don't discover until they're already in production. Assembly speed gets locked in during your first few weeks of design. Senior engineers design for fast assembly from day one. Inexperienced teams design products that technically work, but require slow, complex assembly processes that destroy profitability at scale. The assembly method that determines your unit economics gets decided before you ever talk to a factory. And fixing it later usually requires a complete redesign most startups can't afford. Let me show you why. Point 1. The assembly time math that destroys unit economics. Let's start with simple math. Add 30 seconds to your assembly process. That doesn't sound like much, but at 10,000 units, it becomes 83 additional hours of labor. If you're talking U.S. manufacturing, at $15 to $25 an hour, that's an extra $1,200 to $2,000 in extra costs. And that's just one small inefficiency. Most inventors obsess over shaving pennies off material costs, but they completely ignore labor time. Here's the reality. You can negotiate better material pricing, but assembly time is fixed by your design. Factory workers assembly hundreds of units a day don't operate like prototype engineers. Timing variations appear. Workers slow down when processes are awkward. Your estimated assembly time becomes unpredictable. Then bottlenecks appear. New factories must add workers or run additional shifts, which multiplies labor costs. Quality control becomes harder too. Complex assembly sequences lead to mistakes. Mistakes lead to rework, and rework destroys margins at scale. Manual assembly that feels fine at 100 units becomes brutally expensive at 10,000 units, because the assembly method you designed in CAD determines whether automation is even possible. Point 2. Why assembly speed gets locked in during week 1. Assembly efficiency isn't decided during manufacturing. It's decided during early engineering. In your first CAD models, joint types, fastener selection, assembly sequences, all determined during your earliest design sessions. Part orientation matters too. The way parts align and mate together determines how easily workers can assemble them. Tolerance decisions also affect assembly speed. Loose tolerances create alignment problems. Tight tolerances require force or adjustment. Both slow production. Material choices influence assembly methods as well. Different materials require different joining techniques. Change the material later, you often redesign the entire assembly. Fasteners are another hidden factor. Each unique fastener adds time. It also adds inventory complexity. And tool changes during assembly slow down production lines. Assembly fixtures are determined by part geometry. Complicated geometry requires custom fixtures, which adds setup time to every production run. Senior engineers think about automation potential immediately. Junior engineers focus only on making a prototype work. And those early decisions create permanent assembly limitations. If assembly decisions are more complex than you realized, subscribe to my channel. I break down the manufacturing realities that determine unit economics before production starts. These are the engineering choices that separate profitable products from expensive mistakes. Hit subscribe so you can get these insights before you make irreversible design decisions. Point 3. The hidden assembly decisions that create permanent costs. Some assembly choices look harmless during development, but they quietly create expensive production problems. Take snap fit connections. They work beautifully in prototypes, but in production, they often require precise force. That creates timing variations between workers. Efficiency drops. Then there are threaded fasteners. Each screw requires several turns. Add 5 screws to your product, you just added significant assembly time. Now imagine that across thousands of units. Adhesive bonding is another trap. It seems simple, but adhesives require precise application and cure time. Suddenly, your assembly line slows down, waiting for parts to set. Press-fit connections can also backfire. They may require hydraulic presses at scale. That means equipment investment and slower assembly cycles. Electronics introduce another challenge. Wire routing and connector installation, designed for prototype convenience, but in production, it creates cable management headaches that add minutes to assembly assembly. Multi-part housings create alignment issues. Workers must carefully position parts to achieve proper fit. That extra attention slows down every unit. Even tool access matters. If workers must reach awkward angles or use specialty tools, assembly slows dramatically. These hidden decisions create permanent cost structures. Point 4. How senior engineers design for fast assembly. Experienced engineers approach design differently. They plan the assembly sequence first before detailed CAD work begins. They visualize how workers will build the product hundreds of times per day. Part consolidation is a major strategy. Combine multiple components into one part. Now you eliminate fasteners and reduce labor time. Standardized fasteners are another improvement. Workers use the same tools throughout assembly. No tool switching, no confusion. Self-locating features built into the geometry are powerful. Parts align automatically. Workers don't need fixtures or measurements. Error-proofing is also critical. Design features make incorrect assembly physically impossible. This reduces rework and quality inspections. Material selection also considers assembly, choosing joining methods optimized for production speed rather than prototype convenience. Finally, senior engineers evaluate automation potential early. Successful products eventually transition to automated assembly, but only if the design allows it. If automation isn't considered early, scaling becomes difficult. Assembly speed determines profitability, and it's decided long before manufacturing begins. Labor costs multiply with volume. Early design choices lock in assembly time. Hidden assembly decisions create permanent cost problems, and experienced engineers design efficiency into products from day one. Assembly speed isn't a manufacturing problem you can fix later. It's a design decision made in your first month of engineering. Your material costs might look great on paper, but assembly time is what actually determines whether your product scales profitably. You now know that assembly speed gets locked in during early design. By identifying these issues in your specific product requires engineering expertise most inventors don't have. At Rapid Product Design, our product evaluation service analyzes your concept for assembly efficiency and manufacturing cost drivers before you invest in prototypes or tooling. We use the same process I've refined over 30 years and over 2,000 products to help you avoid assembly decisions that can destroy unit economics. So click on the link below to book your free strategy session. We'll show you whether your design can support profitable manufacturing at scale. And when you're done, watch my video on design decisions that kill products at 10,000 units. It covers the other manufacturing constraints that only show up when you try to scale.